Hey guys, how you doing? I wanted to put together a solutions video for the practice assessment for you. So it's going to be two parts. The first part is the graphing. The second part will be the analyze and the solving. So first thing, graph on the following coordinate plane. Just not saying go put it in Desmos and send me a screenshot. So you needed to graph this by hand on the coordinate plane. So I have to figure out what all these numbers mean. So the first two is my amplitude. The 3 is my midline. So I can go ahead and put that midline in right at +3. My amplitude means my max is going to be 2 above that. My minimum is going to be 2 below that. So my max will be 5, my minimum will be 1. I have a horizontal shift. So a sine curve starts on the midline, but instead of starting on the y-axis, I have a horizontal shift of pi/4. So my first point where I'm going to start is going to be right there at pi/4 3. And then this 2 is my frequency. So that means I'm going to have two full sine curves within a distance of 2 pi. Or if you wanted to figure out the period, it'll be 2 pi divided by b, which is 2. So the period will be pi. So I'll have one full sine curve within a period of pi. So from pi/4 to 5 pi/4, that'll be my period. That is a distance of pi, so that'll be my period. So I now know my curve is going to end here. Halfway in between is where it'll cross the midline again. The last thing I have to worry about is this negative out front. Typically, your sine curve is going to start up, come down, and end at the midline. The negative means it's been reflected. So I'm not going to start up. I'm going to start down. Go up to my max and end at the midline. So I'm going down, which means I'm going to my minimum, which we said was 1. So halfway between those 2 points at pi/2. And then my maximum is 5, so halfway between these points. And then I can connect my points with a sine curve. So that is what one sine curve. And I want to do it between -2 pi and 2 pi, so I'm just going to continue at every mark. So I'm going down to my minimum, back to my midline, up to my maximum this way. And working to the left, my maximum, midline, minimum, midline, maximum, midline, minimum, midline, maximum. And I will finish my sinusoidal graph. That's what the graph of number 1 should look like. Let's take a look at number 2. This time I have a cosine curve. Again, I'm hand drawing it on the coordinate plane. My amplitude is 4. My midline is -2. So again, I'm going to put that midline right in first at -2. The only other number I have is my b value. It's 1/2. So again, in other words, I'm going to have 1/2 of a cosine curve between a distance of 0 and 2 pi. Or if you want to do it with the period, I'm going to have 2 pi divided by 1/2, which is 4 pi. So from negative 2 pi to 2 pi, that is a distance of 4 pi. So I will have one full cosine curve on this graph. So my f2 to 4 means I'm going to start at negative 2. I'm going to go up 4 for a maximum at positive 2. My cosine curve starts at the maximum on the y-axis. As I do not have a horizontal shift, I'm going to start there at 2. It's going to cross the midline halfway, and then I'm going to go down to my minimum. So negative 2 down 4 is going to minimum at negative 6. Going left halfway at negative pi is going to cross my midline, and I'm going to end at negative 2 pi, negative 6. So my cosine curve will look like that, and that is what my graph should look like. So if I'm focusing just on 0 to 2 pi, that is where the half a curve comes in. So I have 1/2 of a cosine curve. If I take the left side and move it over to the right side and continued it, I'd end up with a full cosine curve. So I do have one full cosine curve within that period of 4 pi. Let's move on to the equation from the graph. So again, I'm looking for my key points. What's my amplitude? What's my midline? Has there been a shift horizontally? My H shift? And then we got a couple ways to go. We can look at it whether it's cosine or sine. So I'll do both for you. And then the frequency, how many curves occur in the 2 pi period. So this goes from negative pi to pi. So how many curves occur? So my maximum is 3, my minimum is negative 1, which places my midline right in the middle at positive 1. From positive 1 to my maximum is 2, to my minimum is 2, so that must be my amplitude. And let's take a look at the frequency. So if I'm going to do a cosine equation, I have one full cosine curve here. I have a second full cosine curve here. And then I have a half here and a half there. So I have essentially 3 cosine curves. So that's going to be my frequency. If I'm doing a cosine graph, I have no horizontal shift as it starts right at the maximum on the y-axis. So let's start with the cosine equation. We said our amplitude was 2. My frequency is 3. I have no horizontal shift, so there's nothing else in parentheses. My midline is at 1, so I have plus 1. So that is the equation for the cosine curve. If I were to do a sine curve, everything stays the same, except for my horizontal shift. So looking for sine curves, I have one sine curve, two sine curve, and this little part over here will give me my third. So the frequency is still 3. So if I was going to do a negative sine curve, I'd start right there on the midline. But I'm guessing at what that point is. It's not an exact point. So I'm going to start at this point, which gives me a horizontal shift of pi over 2. My other option would be to go this way and have a negative pi over 2 horizontal shift. So the amplitude is still 2. Frequency is still 3. If I'm going to the right, it's going to be minus pi over 2. If I'm going to the left, it's going to be plus pi over 2. Both are correct. And then I have my midline of plus 1. So the other way to get that 3, depending on how the graph is, to find the period. But again, this isn't an ideal graph to do that with. If I were to look at my cosine period, it starts there, it ends there. This part, I would have to guess at. The period is actually 2 pi over 3. So when I divided that by 2 pi divided by that, the 2 pi's are going to cancel out, and I'll end up with a positive 3, which is where the 3 in my equation comes from. If it starts and ends at a nice point, it might be an easier way to find the frequency, the b value. But you can always just count the curves within a distance of 2 pi. That concludes part 1.